This is the last video in section 3.6 on the gradient and the directional derivative. We will do example 3.6.6 and takeaway 14. The example asks us to give an equation for the tangent plane to the surface yz cubed minus 2xyz equals 10 at the point 3, 2, minus 1. So we're going to start this example by defining a function. We're going to let w be the function f of xyz is equal to yz cubed minus 2xyz. You'll notice that this is the left-hand side of our equation. We can then imagine that yz cubed minus 2xyz is equal to 10 is a level surface. A level surface where w, the function value, is equal to 10. And analogous to the two-dimensional case where the gradient is perpendicular to the level curves, the gradient of f will be perpendicular to our level surface. So if we have a surface, we're imagining it's a level surface and the gradient is perpendicular to it, well, that is perfect for finding the tangent plane. We can use the gradient as our normal vector. So let's start by calculating the gradient. We're going to need the partials of f, so let's calculate them. F sub x at xyz. I'm taking the derivative of the f function with respect to x, so the first term goes away and I'm left with minus 2yz. F sub y is, or at x, y, and z, so now the derivative with respect to y, I get z cubed minus 2xz, and lastly f sub z at xyz is going to be 3yz squared minus 2xy. Now I need these at the point 3, 2, 1, or 3, 2, minus 1, and so let's evaluate those. F sub x at 3, 2, minus 1 is going to be minus 2 times y is 2 times minus 1, so I get 4. F sub y at 3, 2, minus 1 is, z is minus 1 cubed, so I get minus 1, minus 2 times 3 times minus 1. So minus 1 plus 6 is 5. And f sub z at 3, 2, minus 1 is 3 times y is 2 times 1 minus 2 times 3 times 2. So 6 minus 12 is minus 6. So our gradient vector is the vector 4, 5, minus 6, and this is going to be our normal vector. All we need now is point normal form of the plane, so our tangent plane will be a x minus x0 plus b y minus y0 plus c z minus z0 is equal to 0. I have 4 x minus 3 plus 5 y minus 2 minus 6 z minus minus z plus 1 is equal to 0. So there is the equation of our tangent plane. Of the tangent plane at the point 3, 2, minus 1. And so takeaway 14 is just a summary of what we just did. If f of x, y, z is a differentiable function at, there's a word missing there, or maybe I can just take out a. If f of x, y, z is differentiable at a, b, c, then the gradient in a, b, c gives a vector normal or perpendicular to, oh, the 2's already there, the surface f of xyz is equal to f of abc at point A.